Okay, the purpose of this video is to help you to get from a folder with all your photos in it from the lab report. So you'll have a folder for each of the 12 cameras. There will be 6 cameras on bridges, 6 on logs, and from there you're just going to have to sit down and watch all the videos and count up the number of animal crossings per structure, per log, per bridge. Okay, and that will get you to something like this. Okay, so here we have our 3 pairs at Dr. Flint's and 3 pairs at Starland. It's not important that you know this, but just to give you some context. So here's that first pair was the one near the horse pasture and the bamboo. There's the log, there's the bridge, okay? And then this would be just a fictitious count of how many animals were observed crossing that log, crossing that bridge. I just totally made these numbers up, just don't use them, okay? The third column here with numbers, I guess it's the 4th column, these are the number of nights that the camera ran on that log or that bridge, okay? We're going to need to standardize. So if you run a camera for 3 months, obviously it will get more videos than a camera run for 1 month. And since the cameras will not have been run probably exactly the same amount of time, maybe one batteries ran out, maybe it got knocked over, any number of reasons that the camera might not be running on a given night. We're going to need to standardize so that in the end our dependent variable is going to be the number of animals crossing a structure per night. Okay, so here's all of our data. To get that standardized number, there's 1,000 ways to do this. If you guys are comfortable with Excel, you can just skip this part of the video. It's not necessary that you do it exactly like I do, but here's how I would approach this. Is I would probably copy this, paste it down here, and in these, I'm just going to get rid of this because I don't. What I'm going to have down here is the number of crossings per night. Okay, up here is total number of crossings. Total number of crossings. Okay, here this is going to be standardized. Okay, so we can get rid of those. Now, the beauty of Excel is that you can do these calculations all in one fell swoop. So what you're going to do is you're going to tell the computer you're going to be using Excel to do calculations. So you do that by starting with an equal sign. Equals, right, equals what? It equals this cell divided by this cell. Okay? Yeah, that's right. Hit enter. 0.97 is, that's saying that 0.97 animals, not a full animal, almost a full animal per night crossed that log. Okay? Which makes sense, passes the snip test. Now, if I take this cell and I copy it down, then Excel does all the calculations for us, right? What it does is, and we can pick number pair 12 here. If I click up here, it is now taking the numerator here is the number of total number of crossings for a log 12 divided by the total number of nights that ran. Okay, which that makes sense. Now that I'm thinking about this, we may have a number of nights that's separate for the log and the bridge. So in the end, there might be another, this might be number of nights for logs, and this is number of nights for bridge. And so we can just put in some fictitious numbers here. Maybe it's just the same, everything was the same, but here the bridge got washed out, and so it only ran for 32 nights. Alright, so obviously this is just all fictitious. Okay, bridges, we want to do the same thing. We want to adjust these numbers for those numbers. So we're going to say equals what? Equals 42 divided by 35, enter. So more than one animal per night, which again, 42 divided by 35, I don't know exactly what it is, but it's going to be more than 1.2. Okay, copy that down. Oh, that's weird, we get a 1, yeah, 35 divided by 35. Okay, so these are your adjusted capture numbers. Okay, now what we need to do is use those to calculate some statistics. Okay, now, and I'll just take this and copy it, Control C. I'm going to bring it over to this sheet, and I'm going to paste values. Okay, what that does is it doesn't paste the formulas, because if you do paste the formulas, it's going to be looking for numbers to divide by up above. Remember how we did the equals and the formula? They're not there. We're just going to tell the computer to straight paste those numbers. Okay, here's our numbers from here. Okay, and so what we want to do, you want to do a few things. You want to calculate the average. So we're going to do log and bridge. We want to calculate the mean. And we want to calculate the standard deviation so that we can see how much variability there is. And the other thing we're going to calculate is the p-value. Okay. We'll do the descriptive statistics first. So you're going to do, guess what? Equals, yes, average. Right? Average of what? Average of these 6 numbers. Put a parentheses at the end. If it's giving you some weird error, check to make sure you have the equals, you have your command, and then your range of values bracketed by parentheses. Okay. Boom. Equals average paren range 10 paren. There we go. Standard deviation equals stdev.s, standard deviation of the sample for these numbers, for the log values. Boom, enter, equals standard deviation.s, parentheses. There you go. So we have an average of 0.62 and 0.69, plus or minus 0.3, plus or minus 0.42. Okay, that gives us an idea about the distribution of these values. So, are they different? That's the big question, right? Is this average different than this average, considering the amount of variability that we have? So, again, we want to skip over, if I ask everybody in the class, we're going to have different opinions about that very question. So we're going to make this objective by calculating a t-statistic. We're going to do equals t-test, equals t-test, equal t-test, parentheses, okay? And now the computer's telling you, what I'm looking for, what it is looking for after the parentheses is array 1, which is here, comma, array 2, which is here, comma, the number of tails, you can use 2 tails, comma, type, and we're going to do paired sample t-test. So what that does is it is specifically comparing this number to this number. this number to this number. Now, it does calculate and compare the averages of these two, but it pairs those in a statistical sense. Okay. K equals t-test. We have array 1, array 2, two tails, paired sample. When you hit enter, the number in that box will be your p-value. And remember, how do you interpret that p-value? If that number is less than or equal to 0.05, then we can be 95% confident that 0.69 is greater than 0.62. If the p-value is above 0.05, so if it's 0.06, then the difference between 0.62 and 0.69 is not different than random, and we cannot say there's a difference. So, there you go. If we said that more animals cross the bridge than cross the log, we would be wrong almost 40% of the time. I am definitely not comfortable with that. Okay, so i.e., no difference. Animals, and there you go. I mean, that's the reality of these kind of investigations. If you push that button and you get your p-value, you know your answer, and you have all the work that you've done is sort of tied up right there in that moment. Okay. Now, here are some other theoretical data sets. These are not, well, I mean, I guess we could have 2 animals crossing per night. Pretty high numbers, but regardless, you will come from here with your data. The point of this is just to show you again. I'm going to tell you one more time, go through this process again, one more time of calculating our means, standard deviation, p-value for logs and bridges. Okay. Equals average, parentheses, equals average, bridge, over here, parentheses, standard deviation equals std, s for log, and I think, no, we can't do that. Standard deviation s for bridges. Okay. P-value equals t-test array 1, comma, I don't put the parentheses yet because that is at the end of the whole function, comma, array 2, comma, two tails, comma, paired sample, then you put the parentheses. Alright. And again, no significant difference. Okay, so you are a long ways towards having all of your results done for this experiment. One more thing is to make a graph. Okay, we'll make a graph for this data down here, and the way you're going to do that is you are going to highlight your 2 treatments, log and bridge, and you're going to highlight your averages. You're going to go to insert, and you can do recommended charts if you want. I just go right up here to bar chart, and then you can play around with this however you like to do it. I mean, I just try not to get too fancy with this stuff. I would do either 3D or 2D, whichever tickles the fancy. We'll do 3D next one. Super fancy people. Okay. The preferences on here. This is getting closer. We can see clearly here that the log average is greater than the bridge average, which it was 2.26 versus 2.0 something 7. I am not a big fan of these scale marks in the back here. Although I'm not able to click on them. There we go. I would just delete them. Well, leave them. No big deal. Chart title, I would not put your title on here. You're going to write a figure that goes underneath this. And watch when you delete this. It stretches the whole chart, and you can see the patterns better. I think that the space is better used there. Over here, you can add, I would add a axis titles, right? And over here, what is this axis? This is the number of crossings per night. This, you don't really need a title down here. It's on logs and on bridges. So I'll just get rid of this. Yeah, it stretches the whole chart out. And then you're going to put on your error bars. Okay, so again, you're going to go here. You are going to I think the problem is I used the, I think it's because I used the 3-dimensional. Let's just do 2D. Now I can get rid of these damn lines. Oh, gone. Yeah, so go with the 2-dimensional. Okay. Click here. Same way you put your axis titles, you're going to put error bars. Go over to the little arrow. Click here. Go to more options. Because you don't want to put a standard error. I don't know how it's calculating. Standard deviation. No, it's not. It's not. This is not right. Like you see, if I did standard deviation, we calculated standard deviation of 0.3. This is saying there's a standard deviation of 1 or 2. So go to more options, and down over on this error bar options, we can do custom. And then I'm just going to shoot for something in the middle of this, 0.4. I'm going to say 0.4. I'm going to say 0.4. Okay. And that will get you to your graph. Okay, so we see, again, p-value is pretty high, so that means there is no real difference between these. And if you just have that mean that looks like the mean crossing log is higher than the one crossing the bridge, but when you throw in this error bar based on standard deviation, you can see there's a lot of overlap. Okay, and then you can just take this whole thing, you can copy it, and you can put it wherever you want to. Right? You can put it right into your lab report. Okay, so you start with a count, you standardize by trap nights, you calculate your mean, you calculate your standard deviation, your p-value, you insert a bar chart, add your axis titles, and you add your error bars, right, including the custom value. Okay. So that should be what you need to be successful here.